Hello to all my geometry students out there, and welcome to week 2 of online instruction. Hope everybody's doing well and staying safe and healthy with their families. And I miss seeing you guys, so hopefully we'll be able to see each other again soon. In the meantime, I just wanted to touch base with you guys, let you know what's going on before we get started with today's lesson, what to expect this week, and then upcoming in the next week or so. All right, so for those of you that are keeping up on the assignments and watching the videos, thank you for that. I'm going to continue to try and post the content as often as possible, try and get as much information to you as I can to help you learn the material. All right, so obviously we've got the PowerPoint notes that you can be reviewing, as well as the videos that I'm posting. Don't forget about all the videos that are available on Khan Academy as well. Make sure that you're keeping up on the daily bell work. I'm grading that weekly just like I always do, but there is assignments Monday through Friday. Okay, so there are assignments on Friday as well, so don't forget about those. Khan Academy should only be 1 or 2 assignments per week, so try to keep up on that as well. As always, do Friday before midnight. Coming up next week, we're going to go ahead and try to attempt our first online quiz. All right, and I'll talk to you a little bit more about that towards the end of the week. This week, I'm going to go ahead and try and wrap up chapter 10 on area of polygons. So I'll be posting a couple lessons and then maybe some practice exercises as well. Again, if you're having trouble with any of the Khan Academy assignments, email me or send me a screenshot of the problem. I'll do a quick video and post some solutions on that towards the end of the week if I need to, if you guys are struggling with those assignments. All right, so with that being said, let's go ahead and get to the lesson for today. If you need anything, again, just reach out to me. Let me know how I'm doing. Give me some feedback. Post it in the comments, either in the post in Google Classroom or in the comments on the YouTube video. All right, let's get started. Okay, so today's lesson is going to be on section 2, the second half of that, and we're talking about composite figures. All right, now we've talked about composite shapes previously during the first section when we started talking about area, but it was just basic figures talking about a combination of triangles and rectangles. Remember, a composite figure is just a figure made up of simple shapes. All right, so we're going to mix in some additional shapes into our composite figures now. We're going to go a little bit more in depth, a little bit more complicated on the shapes, and also use some partial shapes as well. All right, so let's go ahead and get started on that. So let's start off with an example from the notes. If you want to follow along on the PowerPoint, I'm going to do a couple of those examples as well. All right, so the first shape that we're going to look at, okay, is kind of like an L shape. All right, so they give us this top part is equal to 15 centimeters. This side part is equal to 12 centimeters. All right, this left side is 21, and then this bottom side is 27. All right, so we need to use the dimensions that they give us to try and find any of the other missing dimensions that we've got. Okay, so we want to divide this up into 2 rectangles. Okay, so we're going to kind of split that up there. All right, so we're going to find the area of this section, and then we're going to find the area of this section, and then of course add their areas together, and that will give us the total area. Okay, so I've got a rectangle here. I've already got the dimensions of it. All right, so we're going to call this one rectangle 1, and then we'll call the other one rectangle 2. So that way we can kind of keep track, and then we'll add those together. All right, so let's start off with rectangle number 1. I'll do that one in blue so we can keep it separate. So we've got a length of 15, a width of 12. So again, area of the rectangle is just going to be length times width. So I'm going to do 15 times 12, and that will give me my area for this section. All right, so 15 times 12 in our calculator is going to give us 180. Okay, so there's the area of that first blue section. Okay, right there. All right, then we're going to do the red rectangle. We want to find out or figure out the area of this rectangle here, this whole area. All right, but we need the dimensions, length and width there as well. So we'll call that area 2. So they give us the width which is 27. Okay, but I also need to know this side here. Okay, but they only give me this far side where this whole thing is 21. All right, so what we're going to do to find that, we're going to take the length of this whole side. So let's say if I had extended this up like that, all right, if that one's 21, then this whole side has to be 21, right? All right, this portion is 12 and the whole thing is 21. So how am I going to find out what's left? Well, I'm going to subtract the whole thing and the 12 portion, and that'll tell me what's left. So 21 minus 12 gives me 9. So that means that this section right here has to be 9. That one's 12, and which makes the whole thing 21 to match the other side. Okay, so now I've got the dimensions, 27 by 9. So I'm going to put that into my calculator, and that's going to give me a total area for that section of 243. Okay, now all I have to do is add those two together, and that'll give me the area of the entire figure. All right, so I'm going to do 180 plus 243, and that'll give me a total area of 423 square centimeters. All right, so that first example was pretty straightforward, pretty simple. We've done ones like that before. So let's take a look at the second example, which is a little bit more complicated, and throw in an additional partial shape. All right, so here's the shape that they give us. We want to find the area. All right, so this one we're actually going to divide up into 3 sections this time. Okay, so we're going to first draw a line straight across here, and we're going to form up a right triangle there, all right, because we can find the area of that. All right, then we've got a curved piece here. All right, so what we're going to do is that we're going to draw a line straight across here, and we're going to divide this into a rectangle and then a half circle, okay, or a semicircle. All right, so we know how to find the area of a circle, we know how to find the area of a rectangle, and then of course triangle. All right, so we're going to split this up into 3 sections. All right, so the triangle is going to be the first section in blue, and the rectangle is going to be the second section in red, and then the half circle is going to be the third section in green. Okay, all right, so let's start off with the triangle. Let's take a look at the dimensions that they give us. So they give us this portion here is equal to 10.2. All right, they tell us from here to here is 7.8. Okay, from there to there. All right, and then they tell us that this section from here to here has a length of 3. Okay, so they want us to find the area of that. So let's start kind of piecing together what we need. We're going to need the base, okay, and we're also going to need the height of our triangle in order to figure out the area of this first section. All right, so our base we're going to use as this dotted line here. Our height we're going to use as this portion right there. Now it tells us from here to here is 7.8, but it also tells me from here to here is 3, just like it is on the other side. So in order to find the length of that section there, I'm going to subtract these two. So that means that this portion here is equal to 7.8 minus 3, or 4.8. All right, so there's my triangle. I've got 4.8 here. I've got this side, which represents the hypotenuse, and I need to find this side, which is going to represent my base. So 2 sides of a right triangle, I need the third. You know what to do, Pythagorean theorem. All right, so let's go ahead and find that. All right, so we're going to try and find our base. We'll call that B. Okay, so we're going to do A squared plus B squared equals C squared. Okay, we're using Pythagorean theorem to find the length of that side. All right, so we're going to do B squared equals 10.2 squared. All right, so we'll put that into our calculator, and then we're going to subtract 4.8 squared over to the other side. So 10.2 squared minus 4.8 squared. All right, and we can do that right into our calculator. All right, so we're just going to go 10.2, hit the squared key, minus 4.8 squared, and then hit equals. And there is our answer to b squared. So b squared equals 81. So hopefully now we know that when we take this final step, we take the square root of both sides. So square root of 81 and b is equal to 9. All right, so there's that side right there. Now we can find the area of this portion right here, the blue portion, which is our triangle. So base times height times 1/2. Okay, so area of our triangle is going to be 1/2 base times height. Okay, so let's go ahead and put that into our calculator. 9 times 1/2 times 4.8, and the area of our triangle portion is 21.6. All right, so let's move on to the second section and find the rectangle. All right, so let's take a look at the area for the second section, which in this case is a rectangle. So we want to find the area for the red portion. Okay, we'll call that A sub 2. All right, so it's just a rectangle, pretty simple. We've got the width, or we've got the length now, which was the base for our triangle, is also the length of our rectangle. So that's a pretty simple one, 9 by 3. So length times width, and area of that one is equal to 27. All right, so that's the second portion. Now let's do the last one, which is our circle. All right, so we're gonna call that area 3. We'll do that in green. All right, so we know how to find the area of a circle. All right, equation for area of a circle, hopefully you remember, is pi r squared. All right, so we need to figure out the radius of this circle. Okay, so if we were to pretend that it's a full circle and find the area, then we just divide the total area of that circle in half, and that will give us the area of just that portion right there. All right, so from here to here is the diameter, so we want half that. So from there to there, we already calculated is 9. So half of 9 is 4.5. So our radius is going to be equal to 4.5. So we're going to plug that into our equation. So we're going to do 4.5 squared times pi, and then we're going to divide that whole thing by 2 because we only want half the circle. All right, so let's go ahead and put that into our calculator. So let's do 4.5 squared, okay, times pi. Go ahead and use the pi key there, and we'll round it at the end. Equals that. So there's the area of our full circle. Then we're going to divide that by 2 to find the area of the half circle. So divided by 2 equals, and then we're going to round it to 1 decimal place, which is equal to 31.8. All right. So now we've got our 3 areas, 21.6 for the triangle, 27 for the rectangle, and 31.8 for the semicircle. So we're going to add those 3 areas together. So we're going to do 21.6 plus 27 plus 31.8 equals, and our total area for this composite figure should come out to be 80.4. And the units was feet, so our area is in square feet. All right, so there are 2 examples of adding simple shapes together to make one composite figure. We'll stop there for today. Tomorrow, we'll take a look at a couple of examples on how to subtract simple figures from each other to come up with the area of composite shapes.